Hello, everyone. The webinar will start in 1 or 2 minutes. Let us just wait for more guys to join. Thank you. Okay, welcome to join Edgecore Terragraph Certified Solution Introduction. And I am Max. I'm Edgecore Product Line Manager. And today it is our pleasure to invite Facebook Praveen to help us know more about the Terragraph part. Hi, Praveen. Please introduce yourself.
Sure. Thank you, Max. Hello, everyone, and thanks for joining Max and myself in this discussion about Terragraph and about Edgecore products. My name is Praveen Sampath. I work as product marketing manager with Facebook Connectivity.
Yep, today agenda is Praveen will help us know more about the Terragraph. For me, I will introduce a Edgecore 60 GHz solution MetroLinq milestone and do product overview, and I will show you some deployment scenarios. And also reserve the time for Q&A. So if you have any questions, you can just type in the dialogue. So because the time is limited, so we may just reply like 3 or 4 questions. Okay, then get started. Hi, Praveen, please.
Sure. Sure. But let's get started with what is Terragraph and what is Facebook doing here. So let's start with our high-level theme here. One is Facebook cares about reliable broadband connectivity, and we think it's absolutely vital to our digital economy. If you look across, we have lots of new applications that are coming every year that is adding more and more demand for high-speed connectivity. This could be in future AR, VR, and even like telemedicine and other really cool opportunities that are coming up, which require very good high-speed connectivity in order to deliver them. The demand for data has been growing exponentially. It's been the trend over the last few years, and it's going to grow even more. And it's going to continue in the exponential direction. So the demand for data is expected to double in the next 3 years. And at the same time, we have more and more devices that are coming online. So connected devices alone is going to reach about 29 billion by the year 2022. Next slide, please, Max. So what's the biggest challenge that keeps this, like, in order to serve this surging demand is poor last mile connection, right? If you look across the world, there are more than 1 billion people who are still connected to outdated last mile infrastructure. These could be in some cases copper based or other wireless forms of communication, which doesn't scale as the demand for data grows. And there are some good technologies out there that are addressing this gap. For example, fiber to the premise is expanding. But the problem with fiber to the premise is that it takes time and sometimes it's cost prohibitive in certain markets. So it's not a solution for every market or every topology. So this is a precise gap between the surging demand and the supply that Facebook is trying to address. Next slide, please, Max. So what is Terragraph? A Terragraph is a multi-node wireless mesh technology which has been designed to deliver reliable and high-quality internet. So this technology has been innovated with the last mile connection problem as the centerpiece in order to address it. So it uses the unlicensed spectrum, which is 60 gigahertz from 57 gigahertz to 71. With these wide bands available in the unlicensed spectrum, you can deliver very high speeds, uh, up to 4 gigabits per second right now, and in future it could be as high as 6 to 7 gigabits per second using channel bonding. It uses it's a open R protocol to design a resilient mesh, and this resilient mesh is needed in order to overcome the line of sight challenges that we have with 60 gigahertz. And the last, but definitely the most attractive part about Telegraph is its low cost and its faster time to market. So with this Telegraph innovation, we are precisely trying to address the gap that we have between the demand, surging demand, and the supply side. And it's mainly to serve some of the underconnected communities around the world. Next slide, please, Mike. So how does Facebook work in order to enable an ecosystem around Telegraph? We operate in three fronts. The first is the technology piece. Terragraph is a free licensed technology that we have developed in order to provide to commercial OEMs such as Edgecore. We provide the software and firmware piece and also the interoperability piece. And we also work with vendors, in this case, Qualcomm for the chipset and antenna module vendors, to source and to make sure that we validate the chipset to work properly for the technology. And we also work with standard bodies such as 802.11ay and Wi-Fi Alliance in order to make the contributions of this technology standardized so that it can evolve over time and have a roadmap on its own. So that's the first piece, technology innovation and licensing. The second is spectrum advocacy. In a lot of countries, V-band is allowed for outdoor deployment, like in North America, in Canada, in Europe, and in parts of LATAM, 60 gigahertz is allowed for outdoor deployment. But in other countries, especially in APAC region, they're currently not allowed from the regulatory aspect. So we work with our policy team in order to showcase how this technology can be of use for lowering the cost of economics when it comes to outdoor deployment of fixed broadband. And we work with our policy team there and the regulators in order to open up those markets for our deployment. And the last one is the ecosystem engagement. We know that in order to actually make this technology be applicable to the field and to make it relevant, we have to work with ecosystem partners, such as operators that we work with, in order to not just evangelize, but also to do some pilot deployments. So we have done a few, and I'll talk about it later in a slide. So we do evangelism work, and we also do field deployments in order to learn about the technology and to make it better. And we also help our OEM partners go to market with promotion and other pilot trials. So again, just to make it clear, Facebook is not here in order to become an OEM or a system integrator or an service provider. We are here purely as an ecosystem enabler. And Terragraph is a free license technology that we're providing to the ecosystem with that goal in mind. Next slide, please, Max. Just a little bit more detail about the Terragraph's technical breakdown. So it operates in 60 gigahertz spectrum. As I mentioned, it's from 57 gigahertz to 71 gigahertz band. In that spectrum, each band is about 2.16 gigahertz wide. And currently we use one of those bands, either 1, 2, 3, 4, 5, 6, to deliver up to 4 gigabits per second bidirectional throughput. In future, we are adding a feature called channel bonding with the help of Qualcomm chipset. in order to combine across two bands to deliver up to 6 to 7 gigabits per second bidirectional throughput. Second key component is the resilient mesh, which has been designed using OpenR. This mesh is extremely important because operators care a lot about availability. So if you want to design a highly reliable and available network, then this resilient mesh comes into the picture to help you address it. And it also helps you efficiently distribute capacity throughout your network. The third component is the MAC, the efficient MAC and PHY. Unlike the older 802.11ad, this is 802.11ay based and uses a TDD scheme, right, where you have it's a scheduled TDD system, and it really helps in order to expand your network and make it more dense and scalable. The fourth one is a cloud management tool that we provide to our operators, to our OEMs to integrate with operators' management tools. And this cloud management tool helps with configuration, with management, with visualization, alarming, monitoring, etc. And the last one, which is kind of an important piece that's needed in order to deploy Terragraph-based technology, is the network planning tool. We understood right from the onset that for OEMs and operators to truly deploy this network, they need an easy to use network planning tool, because not many people have experience doing wireless, especially millimeter wave wireless deployment. So we have designed a network planning tool called Advanced Network Planner, which can be used for deploying Terragraph-based technology. And it can quickly design and automate a network for you in a given region by using imagery, population data, and other data sources. And it's highly efficient in coming up with this design and showing you also the cost economics of it. And so all these components that are here, the 5 key components, are licensed to our OEM partners, which they can use to make their product commercial. Next one, please. So now we talked about our vision of Terragraph. We talked about the key technology components. Now, where do we see this Terragraph fit in the ecosystem, and what are the applications that we would like to see Terragraph being used for? The first one is fixed wireless access. As I said, it's fiber-like connectivity. So you have speeds up to 4 gigabits per second bidirectional. So this provides fixed operators a complement to their fiber strategy. So in neighborhoods where they cannot trench fiber, or fiber is just not cost economical, Terragraph can be used as a fiber extender in order to provide gigabit connections. So that's the first use case. And you could do that using street level assets like street poles or even rooftops to create the Terragraph network, and use consumer node devices outside people's homes in our offices to terminate the connection and to provide the high-speed internet. The second use case is mobile backhaul. As we go into 4G densification and very soon 5G deployments, street level deployment becomes extremely important in order to give the coverage needs, or in order to address the coverage needs of the mobile network. So we see Terragraph as a good option, and we are doing some trials in the space with some big operators, where it could be backhauling mobile sites, especially 4G and 5G sites, by giving a multi-gigabit connection to them. Third one is, and third and fourth are kind of related, is outdoor Wi-Fi and smart city, right? So Wi-Fi is also going through an evolution change, as in they're going from 11AC to 11AX, Wi-Fi 6, and Wi-Fi 6 requires gigabit backhaul. So some of the current options, such as copper-based technologies, don't really scale up to meet the demand of 11AX routers. So we foresee Terragraph as a good option, and it's just been proven in the field as well, in order to backhaul these new Wi-Fi deployments. And also smart city, in order to connect CC cameras and other smart city security features. Next one, next, please. I had mentioned earlier that we had done some field deployments through which we have learned a lot, and we also made our product better as a result. First one on the left is our first commercial Terragraph network that's live and active right now in Penang, run by YTL Group, Yes Group. So this went live 2019, and it's now serving businesses and homes in the Georgetown Penang region. It's connected about 150 homes, and it's also serving a bunch of businesses in that area. It's delivering a max speed of about 500 megabits per second right now, with a planned upgrade in the next few months. It as of in before COVID, it had about 33,000 unique users connected on this network. One good thing we learned about this deployment, which also validated our value prop, is that the capex for this network was significantly lower than what it would have been with a fiber option. It was 40% cheaper than fiber, and also it was deployed within 4 weeks. Right, the network from start to finish was only 4 weeks to deploy and active. That's the first one. The second one is our trial that we did with in Marco and Mikibuda, Hungary, with Magyar Telekom. Magyar Telekom is a subsidiary of Deutsche Telekom, and we partnered with them to do a full-on trial to connect more than 200 homes to fixed broadband using Terragraph. The deployment took maybe a couple of weeks to actually enable and activate, and the availability of this network exceeded three nines. And we learned a lot from this trial, and the learnings were incorporated into our product. By the way, these trials are being done using our proof of concept called Rev5 Gear. So the white, yeah. So Marco and Mickey Buddha was using our proof of concept gear. And the last one is the one close to our home, which is in San Jose, California, where we use Terragraph in order to provide street Wi-Fi to users who come to the downtown area. There are 500 radios connected via Terragraph via backhaul. 500 radios acting as the backhaul to activate the Wi-Fi hotspots over there, spreading over a 4 square kilometer radius. The availability of this network is pretty good. This is a pretty old trial by now. It's about 2 to 3 years old. And even back then, we could hit an availability of 3 nines with this network. Yeah, so those are the learnings and the trials that we've done in the field.
Yeah, thanks to Praveen to let us know more about the Terragraph. So let me continue to let you know more about the Edgecore certified models. And the MetroLinq is Edgecore CDR solution. In 2015, we are the first one to launch L2.11 AD standard outdoor point-to-point solution, and it can provide 1 gigabit per second speed at 1 kilometer. And also in 2018, we optimize the system and it can achieve 2.5 gigabits per second and 1 kilometer. And also, we are the first one to launch the tri-band, 2.4 and 5 gigahertz and 6 gigahertz OMI point-to-multiple-point solution. The throughput cascade that we can achieve 10 gigabits per second. And today, we are Terragraph certified vendor with the 11AY solution. We also share our experience to Facebook Terragraph and work as a team to launch 11AY solution to the market. And we will continue to contribute CDR solution to the market, no matter it's 11AD or the latest in 11AY. So as you can see, we have more than 5 years on design and deployment experience. Also, we have professional manufacturing capability to fulfill the customer need and speed up the commercial launch. Okay, so let me show more about our product part. MLTG-360 is a MetroLinq Terragraph distribution node. It supports 4 sectors with 4 6 GHz radios. One radio has 256 antenna elements. We have 4 radios, so the total antenna elements are 1024. Yeah, also, it is the beamforming technology with a phase array antenna design. Besides, MLTG-360 can support 360 degrees coverage with 4 sectors, so it can be up to 1.8 gigabits per second throughput in both directions for each radio. So the total throughput is the 7.2 gigabit per second with 4 radios. For the distance, the maximum distance we can achieve 250 meters, and the MLTG distribution node can support a 60 client nodes. And the total EIRP we can achieve 50 dBm. So it is very, very powerful distribution node. For the bracket, for us, we just designed one type for the installation on the pole. The reason is that to deploy distribution node, it is always can be installed on the top of the pole and they leverage on the street furniture. And also it supports like the beamforming antenna, resilient mesh, self-recovery, and self-optimization. So we believe just one robust type to be able to meet urban or suburban environment. And for MLTG, this model, as a role as a distributed node, we provide a full SKU to fit in different applications. For example, if you install one DN here and would like to connect the rest 3 DN, then you just need to choose the SKU to support 270 degrees. The other one is like this right angle. Yeah, you just need to choose the 180 degrees. For the client node, it just support a 160 Hz radio with 64 antenna elements, and the antenna angle is 90 degrees in Edgecore, and also it is the IP60 rating. For the deployment, the numbers of the client node will be more than a distribution node, so the design is very compact and can run the CPE mode. For the bracket part, because for the CN, yeah, it's always will depend on the different environment. So we provided 3 options. The first one is the stainless hose clamps. It is easy of use and can save the installation time. It can be suitable for the installation on the pole without any adjustment on the device. And next one, if sometimes it's hard to get a pole without any adjustment and it can get the better signal strength. So we offer 2 options. One is the vertical and the other one is the vertical with the horizontal rotation. For this one, it can allow to adjust tier up 20 degrees and tier down 20 degrees. For this one, yeah, you can rotate vertical and horizontal angles. For vertical one, you can rotate tier up 90 degrees, tier down 90 degrees. For horizontal, you also can tier left as the 90 degrees and 90 degrees for the right hand. You can almost meet any insolation environment and can get the basic signal strength from the distributed node. So let us talk about the deployment scenarios. Okay, for this one, like Pravin mentioned, yep. So for MLTG products can be deployed on existing street furniture, and each DN node would beam the traffic from the one DN to another DN, and the DN would pass the traffic to the CN device located on the customer's establishment. The CN could then be linked on the wireless gateway or the router or switches to provide the establishment with the connectivities. For the outdoor Wi-Fi backhaul, I think a state-of-the-art solution is also suitable for the Wi-Fi outdoor AP backhaul. For the Wi-Fi, like yeah, probably mentioned Wi-Fi 5 or Wi-Fi 6 or even like Wi-Fi 60E. Yeah, it's easy to provide a wireless gigabit for the clients. But how about the backhaul? Then MLTG solution is high speed with the mesh support and almost no interference now. Yep, it can be the perfect match for the Wi-Fi backhaul. And for the small cell backhaul, yep, this solution can be located with the LTE or 5G small cell to take a role as a backhaul. The latency is extremely low and less than the 800 microseconds per hop. And via MLTG solution, it can enable mobile network operators to deployment size in strategic, smaller coverage with higher capacity. For the smart city part, always know, yeah, most of the likely smart home, healthcare, transportation, they all need wireless gigabit speed to provide service to customers. MLTG distributed node can leverage street furnitures and provide a resilient mesh to form a network with a wireless gigabit speed. And besides, it supports PoE out and can provide power to IP surveillance for the security. And combining the CRS benefit and with the Wi-Fi can establish a wireless gigabit smart city. But let's talk about the long range solution because what we mentioned for the scenario, it seems that all in urban and suburban areas. So if you would like to extend a longer distance from urban to suburban or even from urban to rural areas, they can incorporate ML 2.5 here, and it can up to 2 kilometers to a point with internet uh, terminal. The ML 2.5 can be powered by one of the DN's PoE out Ethernet port. This helps to overcome the limited range of the DN to serve more areas. So it's the whole our deployments design concept. So now I think that we still have the time that we can check from the questionnaires. So let me check that. Okay, then the first question is I think this one is very good questions. So the question is the customers are just to serve the internet, and Cambium is also Terragraph certified vendors. So what is the main differentiation between the Cambium and the Edgecore? Yeah, I think the all of us we are the certified vendors. So we all leverage like a Facebook 11AY technology. And I think for the Edgecore, as I mentioned before, we started to launch even 80 products in 2015. So we launched the point-to-point and point-to multiple point long distance solution. Even that is based on L2.1180 standard. But I think we at that time we still overcome a lot of difficulty, try to migrate from indoor to the outdoor. So we also get a lot of customer feedback. So we optimize the system, and also we have a lot of successful case in worldwide market. Okay, so we have another deployment experience to help customers for the trial. And besides, I think not just the deployment, and because we also have the manufacture capabilities. So I think that's the main reason we still can keep competition in Stuttgart's market. Okay, okay. Further question is as the technical part. I think for the technical part, I think the major one something like the antenna design, and because if you check the Cambium the solution now they use the uh, diverse antenna diversity technology and with the two sectors But for us, we used a phase antenna design. So, and with the forward sectors. So I'm not sure the data from the testing data from can be or not, but from design point of view, compared to the throughput or like the distance, I think that the Edgecore solution should be better than Cambium. Yeah, but we can check it about the data from the Cambium. Did I answer your question? Okay, okay, good. Okay. The other one is probably maybe this question is for you. Cosmo just asked for the Facebook Terragraph any new product roadmap or new activities?
So is the question about does Facebook have a roadmap around Telegraph?
Right. Yeah.
Yes, we certainly do. I think that's one of the key things. Yeah, as I said, these are the innovation that's went around Telegraph is being we are trying to make it as part of the standard, the 802.11 AY. That's the thing. So as 802.11 AY evolves and adds more features, we'll be we'll be bringing that into the Telegraph contribution. And not just that, our chipset vendor is Qualcomm. As Qualcomm innovates around 802.11 AY space, for example, they are coming up with this feature called channel bonding, which is going to be coming out next year. And channel bonding is very kind of combined across two bands, two 2.16 gigahertz bands. So that's going to be added to our to the technology, and not just that, we'll be constantly working with the ecosystem to add more features around the antenna part, the module part, etc., to make it cost competitive and to make sure that we are bringing the latest and greatest technology to the thing. So we definitely have a roadmap planned around Telegraph in the next 2 to 3 years.
Okay, good. I saw another question is okay for the power compound consumption part. For the DN part, the maximum power consumption is 60 watt, 60. For the CN, the maximum power consumption is 15, 15 watt. Okay. Then the next question is how many hop between the DN to DN? Our result, the test result is a maximum is 15, 15 hop that we can support. Okay. Okay. Someone asked the pricing part. I think this one, because if you check the Edgecore website, I just can tell you now, 1 month ago, we just have the one promotion program. We will do the DN and the CN 30% discount. So I think that for the price part, you can just email to us. Then we have the sales team. We can reply to you. Yeah, no problem for that. Okay, let me check other questions. Okay, the other one is asked any plan for the higher gain and the long range CPE. Yes, actually yes, because as I mentioned, we already have experience for the 1180, like a long distance. Actually, for the 1180, I can tell you now we can achieve like the 2.5 kilometers, but we still can keep 1 gigabits per second. So the other one is like you need a 2.5 gigabits per second that we can achieve 1 kilometer. So we will migrate the same, the design concept on the 11AY. Yes, we do will design I mean the another like a cost effective but more powerful the DN and also the long distance the client node. Yes, we will do that. So let me check one. Okay. One question is Terragraph equipment from different manufacturers? Okay. Pravin, I cannot answer this question.
Well, the underlying okay, I guess I can try to answer it.
Yeah,
So the underlying technology is the same, as in we license the same underlying pieces, like I explained in my slide, the different
right.
components. So to all our licensees, so everyone gets access to the same set of innovation and tools in order to make their products. Now, having said that, each of our OEMs have their own unique uh, take on what markets that they would like to go after. For example, as I said, depends on the applications that they're mainly focused on. We have certain OEMs who are focused more on the fixed wireless access place, so providing
Right.
fixed broadband connection to homes and businesses, and their product SKUs are tailored towards that. And there are some who are interested more in building to building connections, and some in long haul connections. And so it depends really on what the use cases that they're trying to go for first and their priority. So based on that, there's actually variations in the products that they're building, and also the cost point at which they're bringing it to the market. Hope that answers the question. Yeah.
Yeah, yeah, yeah. Okay. I think next one should be the last one because I cannot see more. Last question is how about the operating temperature for the DN and the CN? I think the both of the DN and the CN we support from -20 degrees to 55 degrees Celsius. Okay, so I think it should be overcome some severe environment for this range. Maybe we can still have time. Let me see that. So apply to. Okay. The other question is 200 meters maxima also applies on a node to node. Oh, this question is actually now we do not support node to node, but we support DN to node only. So after the node, we need to connect to other like the Wi-Fi router or other devices. So for the DN to DN, maximum distance is 50 meters. For the DN to CN, the maximum distance just 150 meters. So it's based on the current design, but for us, we still try to the enhancement the performance and the distance. But today it is all what we have. Yeah. Oh yeah. This one. Yeah, because yeah, the customer just asked, can we have the detail around like IPv4 because I think for the 11AY Terragraph, we all suggest a customer to use the IPv6 connections only. Yeah, that one, yeah, we already come out a solution. But I'm not a technical guy, but I just know that we use our another one is with the GRE tunnels, so we can rely on the GRE tunnel and to serve the IPv4 environment. Okay, so for the detailed one, please just email to us. Then we have the technical guy can reply them in more detail. But we do have a solution now. Yeah. Okay, I think okay. Is the Edgecore supporting GPS synchronized or just TDMA? Oh yeah, we supported both. For the GPS part, I think now we support IEEE 1588 V2 and also yeah is the TDMA, yeah, time division multiple access is bridging available. Okay. Oh, one question is, it is the going to be sold through the Ignite channel in the other existing one? I think that yeah, that customer should be or existing Ignite the customer. I think yeah, you still can just buy the 11AY products via the Ignite channels, and also I think that you can also buy products from the Edgecore because now Ignite part is just under the Edgecore, so we both can help you for the products the selling issue. Okay, is it possible to enable additional sector on MLTG 300 on a later stage, or are they fixed when you purchase a specific skills? Uh, Oh, okay. Because I think the from the hardware point of view, because before the shipping the samples to customers, actually we already have the different, the antennas and the radios inside. So in the first beginning, you need to choose, yeah, your scenarios belong to need to cover like a 360 degrees or 180 degrees. Because if you check from the product outlook, yeah, it's all the same, but the internal the radios are the and the like the antennas are different. So it is not so flexible for that. So you need to choose the right one, yeah, before we ship to you. Okay, let me check another one. Okay, maybe I go for the oh, maybe I choose this one. Will the presentation showing today be made available after webinar? I think yes. We also will record the film, then we can share on the webinar. Okay, let me check another one. Is it used only for the backhaul purpose or access as well? Oh, I think no. Because if you check the scenarios there, the DN to DN we can do, and behind the DN we have a CN. But for the CN part, you always connect to the DN. But they can use the one Ethernet cable to connect to the like wireless router, or you have a switch. So that one will be for the access. But for the whole CR solution, no. I think we are good for the backhaul, and but for some scenarios, if you can accept the latency, actually we also can do the front haul. But for the access, no, we cannot do that. The question is possible also to use other NMS system to monitor the Terragraph network, perhaps the TRO69 and the SMP protocol. Praveen, uh, for this one, do you know Facebook and also have the like the one more or more the API that the customer would like to use their network management system? Do you know this?
Sorry, can you repeat the question, Max? I didn't catch the full question.
Yeah, yeah. I mean, the question is, the customer would like to use their existing networking system, but
Right.
to monitor or certify Terragraph the products. Can we do that?
Yes, I think yeah, that's definitely an option. That's possible. Right.
Okay. Yeah.
Yes, we do have APIs that we can open up in order to integrate with the operator's existing network management tool.
Yeah. Yeah. Good. Good. Because they just take it like the TRO69 or like a SMP the protocol. But I think if we have the can provide the API should be enough. Yeah. Okay. Here, let me see another question. Okay, if one of the distribution is done and it form a new link and provide a service, yes, exactly. So that's why we call it a resilient mesh. Yeah, the DN then if that dedicated DN is shut down, it will connect to another DN. So we will keep the network still, alive. Okay. Do you need a license to install MLTG 300 and the CN? No, no. I think for the current solution, no. But we do have the plan because for the Edgecore, we have we call it the EC Cloud. We have the one cloud platform. Yeah, it's owned by us. So we also try to just add the whole MLTG products on the EC Cloud management. So if we can manage that, and now the current um, like the management, the package is below or 50 device, it will be the free. But more than 50 devices, yeah, just a 1 year is the 99 USD dollars. Then you can manage like the 250 thousand devices. So also we have a lot of like add-on features. But that one I think, yeah, you can send an email to us, then we can introduce more about our cloud. Okay, then is it possible to enable additional sectors on the MLTG 300 and the later stage? Okay, I think I already replied this. No, I think the hardware is fixed. Yeah. Does AO2.1Q, yeah, give the meshing? Yes. I think now not just the 1Q, and also we provide a VLAN and a Q in Q. So I think that current feature wise that we can do that. How many deployment case by Terragraph now? Praveen, do you notice the audience just asked how many deployment cases by
Yeah.
Terragraph? Yep.
That's a great question. So there have been deployments that have been done by Facebook directly, working with operator partners, and I think there's maybe 6 of them total over the last 2 to 3 years. But having said that, we have I think Max, you can speak to Edgecore as well. We have
Yep.
our licensees doing trials on the field as well, and I think
Yep.
it depends depending on the OEM. It's probably anywhere from 3 to 6 deployments per OEM. Max, you want to add to that?
Yep. Right. I think for the Edgecore part because we just launched, but to be honest, we got a lot of requests and most of them are from the United States and Canada and Africa.
Yeah.
And both and some of the areas like APAC we got from the Malaysia
Mhm.
and Indonesia. I think the most of like the APAC areas because I think it's from the interference point of view because and also it's hard you use the fiber to launch the service. So the gigahertz maybe is a good solution. But I remember, yeah, just one customer from the India part just asked, if we can just launch a gigahertz solution there. I think from our 1180 products, the experience, deploying experience, I think for the POC may work there, but the Indian the government, I think it did not just announce that CRs can use in public. So it
Mhm.
is what we know. Yeah.
Yeah, that's still work in progress to open up India for 60 gigahertz outdoor. I think we are still
Yeah.
working. Yeah, just one more detail on the deployments. As I was mentioning, Facebook Connectivity has worked with certain operators to do fixed wireless access as well as Wi-Fi backhaul deployments in the field, which we have proven to be, performing the way very satisfactorily. And we have certain OEMs who are actually using Telegraph technology to use for building-to-building campus connectivity, right? And also
Yeah.
as a backhaul for smart cities. So these are deployments that are happening right now in the trial phase.
Yeah. Right. Right.
Yeah.
Okay. I think yeah, it is the last question. So I think time is up. So thanks Praveen today. Yeah.
Yep.
Yeah. And thanks.
You're
Yeah.
welcome.
Yeah. And thanks to join the Edgecore webinar. I think if you have any questions, you can just email to Edgecore part, and we do have a sales team and the technical support team. Then if you do not have time, yeah, to just to ask a question to us, just leave message with us, yeah, so we can reply to you. Okay, thank
Thank
you.
you, everyone.
Yeah, have a nice day. Yeah.